Hello and welcome back to our live stream classes on Fusion 360 for beginners, aimed specifically at woodworkers. So we're going to start today and do something a little different from our usual follow-along classes. Of course, I do want you to follow along and model these things with me, but we're going to do this in two totally different methods. I've often been asked, what is the best way to think of modeling in Fusion 360? And my answer is that there's actually two totally valid different ways of thinking of modeling. There's a bunch of relatively invalid ways of thinking of modeling in Fusion 360 as well, and you'll see many of those out there on YouTube. Not that they don't work, just that they're not very efficient. And the whole point of using a piece of software like this, computer-aided design, CAD, is not to get something done, but to get something done fast. And if it's not fast, and it's not intuitive, and it's not simple, you're doing it wrong. Just because you actually get there in the end doesn't mean it's a good process. It means you probably need a better one. So what we're going to do is we're going to take the direct approach to modeling a table, and then we're going to take a different approach that is a bit more efficient, but takes a lot more thought. And so what we'll be able to do is go through these two different methods. That we're going to do one in this live class. We'll do the other one in the next live class. And you can follow along with both. I don't think either is going to be particularly complex to do because it's a very simple model. But you'll understand what I mean when one takes a lot more doing and the other one takes a lot more thought. Because what we're going to do in the first one is model it the way we would build it. And in the second one, we're going to model it the way the computer wants to build it. And those two are very different things. So what we'll do, without any more delays, is we're going to start by using our main drawing screen here in Fusion 360. The only thing I've changed from the default setup is perspective with ortho faces here. We've turned that on. That gives us straight lines in our models rather than a perspective drawing, which is a little counterintuitive unless you're used to perspective drawings, and even if you are, I find them to be nothing beyond silly in this context. So we will start by modeling. We create a new sketch, and we're going to create a new sketch on the top because we're going to be modeling a dining table here today. A very simple dining table that is a sort of a standard size. So we will pick a center point rectangle here starting from the middle. Remember, it doesn't matter what the dimensions are when we draw it, because we're going to put the dimensions in manually. We're going to make it 61 inches wide, and scroll out with our middle mouse wheel, and we're going to make the other dimension 27 inches. We're going to do these two tables with exactly the same dimensions, so you'll be able to end up with the same table twice, and the process is quite different, as you'll be able to see. Okay, so from this table, I want to be able to draw several other things. I'm going to make 4 legs. So I will draw a leg. Remember, we're looking down at the top of this table. And I will hit this equal sign. I'm going to constrain it to be equal on both sides, and that makes it a square. Now, if you look at this outside rectangle, you'll see that it has turned black. That means it is fully defined. Fusion knows exactly where to put this table. But this blue one, it's not fully defined. If you have guidelines like these dotted ones, they'll be red if they're not fully defined, and regular lines are blue. So what we need to do is give it some dimensions. I'm going to say that this leg is 1 11/16 thick. I'm going to go in and say that it is exactly 2 inches from the side. In both cases, 2 inches from the side. That's fine. I haven't copied this from one to the other because when you're actually modeling this thing, you might want to move these independently of each other rather than having it the same distance from both ends. Maybe not, but sometimes it's nice to keep that option open. So I'm going to draw some guidelines. I'm going to draw a guideline vertically. Remember, this is across the table, not actually up and down, because we're modeling looking down at the table. And I'm going to draw another one, and then I will select both and hit X to make them guides. It knows where those are too, because it is from a known center point in both directions. Now if I click on this mirror and I double click on this square, I can mirror it across this center line and it will go over to the other side, as you can see. Now if I do the same thing and I double click on both, I can then mirror it across to the other side again. Not bad. Now I want to have a dividing rail going between each of these. So I'm going to draw a line as a guide from the center point to the other center point. Now see, when I have that connected into the center, there's a little triangle that shows up to tell me that is indeed the center. I'm going to do the same thing over here. I only need to do it on one side because we're going to draw these and mirror them over. And I will again select both of these and make them guidelines. If I draw my center point rectangle from the center of that guide and I touch it up against that leg, I already know that it is the right size. And I could do the same thing on this one as well. Now I want those to be both the same, so I'm going to hit equals and I'm going to pick this one and I'm going to pick the other one. And now they are both the same width. If I hit D or click this dimensioning tool, I can say that I want from here to here, the two outsides of our rail, and I am going to make those 11/16 across. And you see it's done that for both of them here. If I want to check, I can hit I for inspect, and I can click on the top line and the bottom line, and it will tell me the distance between them is 0.688 inches, or 11/16. I can do the same for this. I need to select the right one. I need to select the two outside pieces, and again they will say 0.688 inches. I mention this because this dividing line here that is not at 45 gives the visual impression that this leg is that this rail is thicker than this rail visually, but I guarantee you they are not in the actual model. All right, so the only thing we need to do now is draw those across. So I will create a mirror. I will pick the upper one and mirror it across. I will right click on the background and say repeat mirror, double click on the left one, and again mirror it across. And now we have all four. Now the nice thing about that is that looking at this from the top, if we're going to have stretchers on the bottom of this table, we can actually use the same guides. Now in this case, we're not going to have stretchers because this is a dining table and putting stretchers at the bottom of a dining table would make it rather difficult to sit at. But if this was going to be a case piece and we were going to have drawers and such, we would be able to put those stretchers at the bottom without drawing any more geometry in there. Now, while I'm at it, I'm actually going to put in a couple of extra guides on the bottom of this table because this table is going to be a bit on the flimsy side. So what I'm going to do is, I am going to take this center point rectangle, I'm going to draw it out, and I'm going to connect it in with the existing lines that we have. And I am going to create just one more dimension for this. I will say that, oh no, I'm going to use the equals parameter. I'm going to say that this is exactly the same width. If you find it difficult to select one, you can just click the left mouse button and hold it. And then if you go over the two possibilities here, it'll let you pick the one that you want. Sometimes that's easier than trying to mouse over the right one. Again, we'll do the same thing over here, and I'll make sure I pick the right one. And now that should be exactly the same width as the others. Now, do I want to have another stretcher in here, or another rail, I guess, to make sure the table is stable? Yes, I think I do, and what I'll do to make that happen is, I will say create rectangular pattern. I'm going to double click on it, pick my direction, it's going in one direction there, and I will say symmetric. Now the only thing I need to do is drag it over to be the spacing that I want. I don't want it to be exactly in the middle, I want it to be exactly 14 inches over, because that will give me a little more structure toward the center of the table where there are fewer legs. And I think that will do it. I'll say OK, and now we have all these lines as if we were looking at the table in an X-ray diagram from the top. I'm going to hit Finish Sketch. Now, the first thing that I'm going to do is draw the tabletop. I will hit Extrude, scroll over by holding the Shift button and rotating using the middle mouse button, And instead of picking each of these components one at a time, like this, what I'm going to do is I will hit extrude and select the whole box, just by clicking and dragging. Now, that can work, and that can give you some problems if there are things you don't want to select. But once you have it selected, you can always deselect and reselect anything you want. Now, I want the tabletop to be 1 1/16" thick, and I will say New Component. Now, remember that a component is like a file folder with a bunch of bodies, which are like sheets of paper in it. The bodies are realistically pieces of wood in this case, but they could be anything, any physical object that is a single cohesive and coherent structure. And you can put as many of them or as few of them, like one in this case, in a component, which is like a folder. And if you want to organize things more later, you can always make folders and put folders inside folders, as many layers deep as you like. So I've turned the sketch back on because, of course, after doing one thing, we're not finished with our sketch yet. I'm going to select the 4 legs. And I am going to drag those down so we can see what we're actually doing is going in the negative direction. We'll say New Component, and instead of making them -9 inches, minus just means away from the plane we're modeling on in the negative direction, in the down direction in this case. You can always flip them around just by changing the sign, minus or no minus. You don't have to type plus, just get rid of the minus and it'll do it. I'm going to make this table about 29.5 inches tall, so we'll make this -28. And that will give us a height just under 30 inches, I guess. Well, a little over 29 in this case, because that top is rather thin. All right, that's pretty good. Now I need to make these other rails work. 1, 2, 3, 4. You can drag things in if you can't select them. But in this case, we'll do that. We're going to make these -2 3/8. And instead of join, again, we're going to say New Component. Now, before we get ahead of ourselves here, what I want to do is go up and name these components. We're going to call these rails, better if I can type, legs, and top. We just double click on it and type a name. Now, I think we're doing pretty well here. That looks like a fairly standard table setup. They're a little narrow, but I think that gives a nice impression. The only other ones that we want are these inside pieces here, 1, 2, 3. And I'm going to say New Body because I don't need a new component. Those are still going to go in with the rails. And instead of a distance, rather than typing it in, for efficiency's sake, I'm going to make it go to the bottom of the existing ones right there. It always changes back to join if it can join them together. So if you don't want it to join, which we don't here, I want to make it go in as a new body. See, it's created a bodies folder. I'm just going to select all 3 and drag them into the rails. So if I now scroll out, I can turn off my sketch and we can see we have a table, which actually looks pretty good. After a few minutes, we've got a working table. And if I turn off the rails, you can see the whole rail assembly is one component, the legs are another, and the top is a third. That's a fairly good, straightforward way of dealing with this. So we have our table. If you're going to show a client a model of a table, that would be perfectly fine, and you could actually just stop there. And that's something I wanted to talk about a little, and that is modeling what you need to rather than modeling everything. I've seen a lot of models on here where people have gone to the extent of actually importing the specific screws they want and modeling things so they rotate and join and everything. And if modeling is your pastime, if it's your hobby, if that's what you're doing to have fun, that's fine. There's nothing wrong with modeling all that level of detail. But if, like me, you are designing furniture for construction, this might be enough. I don't need to make it look any different from that. For example, a lot of people will take the time to go in and chamfer all the edges in the model. Well, I know I've got to chamfer the edges on the final piece. I mean, I don't need to put a big chamfer on them, but I know I need to break that edge. I don't need to do the edge breaking in the model because it's going to take me 10 minutes to go through and make sure they're all broken in the right way when I already know I have to do it. This is an instructional diagram for me. And when I show that to particular client or to the school for a model that's going to be used in a class, they're not looking to see if I've taken the time to chamfer the edges on the model. Now, if what you want is perfection and all that's totally fine. It's not a criticism. It's just, don't feel like you're not doing it right if you're stopping at a point and saying, this is enough detail that I know exactly what I'm going to build. Or this is enough detail so that when the client sees it, they get exactly the impression I want them to have. And that's enough. So in this case, we don't need to do any more, but we're going to do more because what we actually want to do is do some decorative joinery on this. The joinery is going to be visible on this table. Now, even if the joinery wasn't going to be visible, I always think it's a good idea to model your joinery just because it makes it a little easier for you to figure out how to build it when the time comes. You don't have to model it so that it's exact, but I would suggest modeling it so it is at least friendly enough to use. So what we're going to do is we're going to turn the top off, and first we're going to look at how we attach the top. Now, there are many ways to attach a tabletop, but I think the best way to attach a tabletop is actually to use dowels in this case. And a lot of people will come back to me and they'll say, well, I want to use pocket screws. Well, okay, use pocket screws. Or they say, I want to use table buttons, which are these little clips that go on in a groove around the top of the table. And they'll say that will account for expansion and contraction over the seasons. Yes, yes, it absolutely will. And then they will go on and they will say, and if you glue dowels into the table, it won't account for that. And yes, that is absolutely true, but my idea is not to glue dowels into all the holes in the table. So I'm going to create a sketch on top of this leg, and I am going to project, actually, no, I'm not going to bother to project the other leg. I'm just going to draw on one leg. So I will take this line tool, and I'm going to draw a center point line from the middle. You can see the little triangle, all the way down to the middle on the other side. And I'm going to hit X to turn that into a guideline. Now, I will create a round circle in the middle here, and I'm going to make that circle, hit D for dimension, 3/8 of an inch in size. That looks fairly good. I think that works for us. I will hit Finish Sketch. Now, I'm going to go in, and I'm going to extrude that. Now, I actually want to extrude that in two different directions, so two sides. And if we look at it from the side, scroll around, I apologize because I'm doing this on a laptop and the screen is relatively small, so you're having to experience this the way I experience it. So I want that to be exactly 1/2 an inch up. I think I'm actually going to make that 3/8 of an inch up. And in terms of the down direction, 1.5 inches seems totally fine. And I will say new body. Now, these are going to be hidden, and we're going to be using those separately. So I will say new component. And I will call this top dowels. Go back to our main component. And I'm going to say rectangular pattern, select bodies. I don't know why faces is even an option here. I don't think I've ever used it. Bodies and components, totally fine. Features, no issue. Faces always shows up as the default. No idea what people are using the face rectangular tool for. So we're going to pick this green direction here because we want them to go to the side. I'm going to drag it over, and I'm going to say I want 5 of them. Instead of one direction, I'll make them symmetrical because I drew the one in the middle, and we'll drag this over. If we rotate down, you can see where those dowels are going to land. And actually what this looks like is very much like the dowel positioning for breadboard ends. But we're not making breadboard ends, and people are going to look at it and say, but wood movement. It's like, yes, yes, wood movement. But what is the solution to doing this when we have breadboard ends? Well, the solution is quite simple. We elongate the holes either on the top or in this rail around each of these outside pins, and we only glue them in one side. The center one, to make sure the tabletop doesn't move, is going to be glued in on both sides with a standard hole. So what you do is you glue them in on the bottom. I always glue them in on the bottom. and don't glue them in on the top. So I make the holes in the bottom of the tabletop a little wider. So this is a 3/8 inch dowel. I will make the hole exactly 5/8 inch wide, and probably even a little wider than that on the outside, because this is quite a wide table. Then when the seasonal expansion and contraction happens, the center doesn't move, and the large tabletop actually rotates, well, not rotates, expands and contracts along this edge, away from the center line, and it only expands and contracts in one direction. It's not pushing away from the other end of the table, just side to side. And so that overlarge hole in the top piece allows it to move, but the fact that it is held constrained with the dowel, it can't move along its length. It can only move along its width. So instead of having to use all the complex fasteners and making table buttons and cutting grooves or using pocket holes that everybody can see and nobody really likes the look of, we've done this with 5 simple dowels on each end. Now I say 5 simple dowels on each end. I've only got 5. We can fix that. We will mirror, again, faces to bodies. These 5 bodies across the center. If you want to see it previewed, you can see it's previewed these 5 over here. We will say OK. That's fairly good. Now, we need to cut those in. And this is where the procedure is going to be a little different next time. But I'll show you that in a minute. So I'm going to say I'm going to cut this long rail with these 10 bodies. Say cut and keep the tools, because the dowels are the tools. I'm going to right-click on the back and combine and hit that combine tool again. I'll do exactly the same thing. I did it a bit fast there because we just did it. I do the same thing, and now I've cut the holes in. I think I'm going to turn that into a component for the moment. I don't need to make it manually. I can just tell it to make a component from one of them. Then I can drag all of them into it. Did I not? Top dowels? Do I not have anything in that? My mistake. I put them in the wrong one. I don't need this component 5. Remove. Okay, I have my top dowels. And the only other place where I need to combine those is with the top itself. So I will pick the top. I will cut that with those dowels. And now I will turn that off. For ease of visibility, not that I'm suggesting you actually use this method for making the dowels, I'm going to go in here and I am going to make these dowels look like they are walnut. We can always change that later, and we will change that later, I think. But now, if I turn off the top, I can see these dark dowels, and they show up so much easier on the model. I'll just turn them off so I can scroll in, and you can see we've cut 5 holes in each side. I will turn off the rails and turn the top back on. And if we flip it over, we can see we have cut mating holes in the other side, in the underside of the top, right there. Not bad. All right, so we're doing pretty well with that. The other thing we want to do is we're going to cut some joinery. Now, I think we're going to have some nice through tenon joinery here. And I bet you're wondering, through tenon joinery, but they all link up at the same place. How are we going to do that? Well, we're going to do that so that they don't link up at the same place. So I will turn off my legs, and I'm going to start modeling on the side of this piece. And I will draw a center point line, or a line between the 2 center points. I will click and make it into a guide, and I am going to create a second one through the center. Now I want to make 3 square tenons on the end of this piece. I'm going to draw 2 and use the mirror command to mirror the second one, to mirror the first one across to make the third. Now, if I make these equal, top right, and top to top, all 3 should now be exactly equal. I will hit D for dimension and make each of these 1/4 inch. All right, now the question is, where are they going to be located? This one is going to be located in the center, which we already know, and this one is going to be somewhere around it. So I will just give it a dimension, and it is going to be exactly 1/4 of an inch from the top, which means the bottom one is now 1/4 inch from the bottom. Now that we've done that, I'm going to go over and do almost the same thing on this other side. You can sort of see where those two are going to protrude. So if I draw another center to center line, both directions, I select both and turn them into guides. I'll draw a center point rectangle here. I will make it exactly equal. I'll give it a dimension. It's going to be 1/4 inch. And I will give it a dimension from the center line. And from the center line, it is also going to be 1/4 inch. You'll see why in a second. I will mirror that by double-clicking on it and selecting the center line to mirror it across. Now, if we look, these don't intersect with each other. Now, the real question is, how big can we make them? If we make these instead 3/8, will that intersect? Well, at the moment, no. So let's go back and take a look at our other sketch and see if we can make those a little larger, because I would like to have them actually be as big as possible. We'll make them 3/8 and see what the spacing is by hitting I, which we've already used, and we can see that that is a little tight. So let's make that 3/16 from the top and give ourselves a little more wiggle room. And if we hit Finish Sketch, we should now be able to see that these can fit nested between each other. We're going to see if that actually works in three-dimensional space in a minute. I think it's going to be very close, so you'll have to stay tuned to see. What I'm going to do is I'm going to select these three, the three tenons on one piece, and I'm going to extrude them. I'll turn the leg on, and I am going to say to Object, to the outside of this leg, and we will say New Body. So we have now created those three tenons. Turn the legs off, and you can see where they are. If we hit Extrude again, I can extrude these two here. I'll need to turn the legs on, say to Object, and pick this outside edge again. We'll say New Body, and again create our tenons. If we turn the legs off, we should now be able to see that these are actually going to intersect quite nicely. One will go right under the other. Now, if you don't want them to touch like that, we can go in and we can say Edit Sketch. And we can make these, instead of 1/4 up from the bottom, we can make it 5/16, and they will go slightly higher. And now they are intersecting. So you can see what would happen if they were actually intersecting. We're going to go back and change that. So instead of being 5/16, we're going to make them, what were they before? 1/4 plus 1/64 is going to be 17/64. Wow. Oh, how I want to go back to just being able to do these in metric. No, I've made a mistake. My bad. Did I add that in the wrong direction? Is it supposed to be 15? I think it should be 15. Right, there we go. Now, realistically, what you're going to be doing is measuring these in real life and creating them so they don't actually intersect. Or, what I would really do is I would create them so they just touch and the holes go through so that they are connected. But one way or the other, we now have our straight through tenons. If I hit Mirror and I pick these three, I can now mirror them across the center, and I will need to do the same thing again. I need these three, 1, 2, 3, 4, 5, 6, and I will mirror them across the center in the other direction. So now I can see that I have all 12 of those. You can see it on the bottom here more clearly. And those tenons now exist all the way through. Great. Now I will do the same thing for these two. Two, mirror it across. And it doesn't matter which direction, I'll mirror it across this way first. So you can see the direction doesn't matter. And I will right click and hit repeat. And I will pick all 4 of those. Let's see if I can find them over here. 1, 2, 3, 4. Select mirror plane. And I'll mirror them along the length of the table this time. And now I have all my tenons perfectly in line. Great, but they're all separate bodies, as you can see over here. So what we're going to do is we will say combine, join, don't need to keep the tools, and we'll join this long rail with, no, we don't want to join it to those. We want to join it to 1, 2. The nice thing about Fusion is when you select something, you can always go back and unselect it the same way. Picked the wrong ones over here too, didn't we? I want it with the 3 that continue from its end and say OK. We'll flip over to the other side of the table. Doesn't matter which way we look at it. We can look at it upside down, that's fine. We'll say combine this piece with its 3 tenons. We'll scroll out and scroll back in on the other side and pick those 3. There's no real point to doing any of this from so far away you can't see what you're doing. Might as well scroll in and see things up close. We're going to do the same thing. 1, 2, 3, 4, 5 pieces. Always make sure you pick the big one first because it usually gets it in a more sensible pattern for the body numbers. We'll do the same thing over here. Combine the short rail with its 4 other pieces. And now we can see that all our extra bodies have disappeared. They've all been joined into these main components. And that's great. Now let's do the rest of the joinery. They join into our legs here, and that's good. So what I want to do is I will say combine, cut, keep the tools, and I'll cut this leg with these 2 rails. I'll cut this leg with these 2 rails. I will cut this far leg with 1, 2 other rails. I could scroll down if I needed to, but I can hit them all from here, I believe. 1, 2. And now, if I turn off the rails, I can see I have all these mortises already cut exactly the shape that I need them. And if I needed to move any of those, if I moved any of the tenons or anything like that, I would be able to change these automatically. They would just fall in line. I'm just going to make it a little more obvious by making the rails out of that dark walnut color as well. I'm not sure if that looks any good, but it does make the positioning very, very easy to see. Now, the only other thing we want to do here is we want to have a way of connecting those inside rails to our outside rails. Now, how are we going to do that? We're going to do that with the same thing. We're going to take these tenons that we made over here, and we're going to connect those types of tenons to these other pieces. Now, when we actually did that, we combined in all these tenons with the pieces that were already there. And what I would like to do is I'd actually like to go back in time, and before we combined all of them, I'd like to copy a few of them. So I'm going to go back in time to before we did all the joins, and I'm going to create a midplane. I am going to create a plane that is exactly between one side and the other. I'm going to create another one, and that is to be between this side and this side. And it will become very obvious why I have done that in a second when I use them. I won't explain it until after I use them, then I'll come back and explain why in particular. So I'm going to turn off those legs to make it easier, and I am going to say that I want to mirror these 2 pieces here and these 2 pieces here across this mirror. And that's exactly halfway between these 2 rails. which means that they're going to be exactly in the middle of that other rail. So we will say new body, and we have now joined those on. Now if I go and I do the same thing, I can mirror these four here. I can select them over here. It's the last four we just created. And I will mirror them across the actual center. We didn't need to create that one because the center point is already there. Not bad. That's great. And the only other thing I need to do is I need to mirror them across this other center line. So I will mirror them. 1, 2, 3, 4. Across this secondary mirror that we just created. And say, OK. Now, there is one thing you're going to notice about these. We didn't draw those specifically to be in that place, and they protrude out past the end. And there are a few ways we could deal with this, but I think the easiest way is to do it this way. I'm just going to turn off these rails. I'm going to turn off the top, and I'm going to pick the outside faces of each of these. I could have done this before. Actually, I probably should have done it before. And I'm going to trim them off. Well, if I have to do them individually, that might not be the wisest of ideas. Can I select them at the same time? 1, 2, 3, 4. No, it doesn't want to let me select them all at the same time. So we're just going to cut them. We will say split body. Wait a second. I'm being silly. I don't need to worry about that. I'm just going to go back and we'll do all those mirrors one more time after having already cut them to length. Sometimes we all make mistakes. Okay, so I'm going to pick the two outside edges of those tenons. I will turn on the rails. And I'm going to say to object. I will pick the outside face and hit cut. And now I have shortened them to exactly the length of the outside of that face. I'm just going to go in here and do exactly the same thing on those two tenons on the other side. I'll turn off the rails to make them easy to select. Turn the rails back on. Say to object and pick that face. And I'm just going to cut them to be exactly that length again. I'll go back and take a look at what we were doing here. We'll turn off our rails and mirror 1, 2, 3, 4 across that line. We'll do it one more time. 1, 2, 3, 4. And we'll mirror them across the center of the whole table. And now we have exactly those in the places we want them. And if you look, they're shorter than the ones on the end. Not bad. What I'm going to do is I'm going to go up here, get rid of these visible construction planes because they're now finished. I'll scroll back to the present after we've combined all those things. Scroll back to the present. All right. And if I turn on my rails, I should now be able to see that we have gotten rid of all the bodies except the few that we just created. Now, if I go in here and I figure out which rails are the outside ones, that should be body 2 and 3. Oops, no, body. Which one is which? 1, 1, and 3. Okay, and I will now say combine. Join. Don't need to keep them. 1, 2, 3, 4. My apologies. I'm going to do that for the one in the middle. We'll rotate around, make it easier to pick the other ones on the side. Never give yourself into trouble for not being able to pick things when you're zoomed all the way out. It's not a skill, it's just about eyesight and coordination, and neither of those is going to be something you'll be judged for in your modeling. All right, I'm going to turn those bodies back on. And now I need to cut those through. So I'll do the same thing. Combine this outside leg with the 3 interior ones. And I will say cut and keep the tools. I'll repeat that for the other side. Cut the long stretcher with all 3 of the inside ones. And I think we have pretty much got it ready. Turn the legs back on. I'm going to hit A for appearance, and I am going to tell it that these middle ones are going to be our regular basic maple, so that you can see where the tenons are actually going through. And I think we are good. So that is modeling the table using the brute force direct modeling approach, which honestly is the approach that I use most of the time, especially when demonstrating. So I hope that's been useful. I'm going to show you in the next class how to do the same model a little more efficiently, using a more thought-based approach rather than brute force modeling it. But I think you will get the idea fairly clearly from this, that there is no reason, even if you do it using this method, that within only a few minutes you can have a complete, lovely little model of a table built. If this was going to be a cabinet or a chest of drawers or anything, you would have exactly the same type of method. And this is one of the truly functional methods for modeling things in Fusion 360. So don't worry if this is the method that you prefer. It is generally the method that I prefer. Despite being slightly less efficient, I think it makes up for it in ease of use for the time that I would save using the other method. Okay, thanks for joining us today. If you don't mind, if you could like, comment, share, subscribe, and all those things that YouTube allows us to get to more eyes if you do them. It's great that we're seeing so many more live viewers on these sessions every day now. Every day that we do them. I mean, we don't necessarily do them every day. I don't want to promise that. But some days we even do more than one. So come back anytime you like. Ring the bell if you want to get notified of when we go live. And if you have any questions, put them in the comments below. Thank you for joining us, and have a great day modeling and building in your shop.